We have got some word problems here, and it's based on Pythagoras property. A 15-meter long ladder, there's a ladder that is of length 15 meter, reached a window 12-meter high from the ground. So the window is at the height of 12-meter from the ground, and this ladder has been placed against a wall at a distance A. Placed against a wall at a distance A, and this ladder is reaching this window at 12-meter high from the ground. Find the distance of the foot of the ladder from the wall. So if we assume that this is the level of the ground, and if this is our wall, and let's say the height of the window from the ground is 12-meter, so if we assume that 12-meter comes here, and then you have a ladder of 15-meter that has been placed against this wall and that's reaching here, and against a wall at a distance A. So what basically it's trying to tell is that if this is your ladder, if this is your ladder, okay, if let us stop this. So the length of this ladder is as given here is 15-meter, and this ladder is reaching, the window is situated here at a height of 12-meter, and this distance against the wall is actually what? A. Find the distance of the foot of the ladder from the wall. Foot of the ladder from the wall, that is, you have to find out this distance A. Okay, so you can clearly see that this is the ground, this is the wall, it's making a right angle, right? And if you have to think of it, this is a ladder. Of course, you can imagine a straight line, right? Imagine a straight line that is passing something like this. Okay, right? So this is 15-meter, this is 12-meter, this 12-meter at the height of 12-meter. So let's write this 12-meter here. Now clearly this is the hypotenuse because this is a right angle, and the opposite side to this right angle is this one. So hypotenuse is 15-meter, and if you remember the Pythagoras property that says a square plus b square is equal to c square, where c is the hypotenuse. So in this case, if you assume that this is a we already have here, this is, let's say, b, so this a square plus this b square, that is 12 square, is equal to this 15 square, right? Okay, so if you solve this, you'll get a square plus 144 plus 225, and if you solve it further, this is a square is equal to 225 minus 144. This will give you a square as 144, then we'll go 145, and this will be 81. So if you solve this, you'll get a square as 9 square. Therefore you'll get as a as 9 meter. Okay, therefore the distance of the foot of the ladder from the wall is actually what? 9 meter. In this problem, a tree is broken at a height of 5 meter from the ground, and its top touches the ground at a distance of 12 meter from the base of the tree. Find the original height of the tree. We don't know this height of this height from here to here. We don't know this one. If I assume that this is the height, then we don't know about this height. Okay, We don't know about this height. Let it be h. We don't know about this. And it is broken at a height of 5 meter. Let's say that it's broken somewhere from height of 5 meter from the ground, and its then top touches the ground at a distance of 12 meter. So something like this happens. It gets broken from here. It gets broken from here, right? From here. It gets broken from this point. It gets broken, and then this top portion falls. So this has been given to us as, this one has been given to us as 5 meter, right? This height, and its top touches the ground at a distance of 12 meter. So this distance has been given to us as from here to here has been given to us as 12 meter, right? Find the original height of the tree. Now you have to find the height of the tree. That's really very interesting question. So you can clearly see that even in this case, you can apply the Pythagoras property because it is making a right angle. How? Let me show you. You can imagine this one as some, let me take some different color. Okay, this one. So what basically is happening is you can imagine a right angle triangle here. Let it be something like this, or straight line. Okay. So this is the base of the ground, then goes something like this. Okay, and something like this. So this is 5 meter, this is 12 meter, this is 12 meter. You have to find this height of this tree. So let's do it. We have this 5 meter, we have this 12 meter, right? So what we can find from this triangle is, we can find this one. Let's suppose this is what is C. Let's assume that this is C. Now, you know from Pythagoras property that says a square plus b square is equal to c square in any right angle triangle. Of course, this is at right angle. This will be therefore hypotenuse of this triangle. So a square, let's say that this is A, and let's say that this is B. So a square means what? 5 square, plus b square means what? 12 square, and this, let it be a c square. If you solve this one, you'll get 25 plus 144 and plus is equal to c square. And if you solve this, you'll get 169 is equal to c square. If you further solve it, you'll get as 13 square is equal to c square. That means c is equal to 13 meter. So this height you got as 13 meter. Now if you would be thinking that we have to find this height h, then how is it going to help us? So can you see here that you have actually found the height of this broken part, right? You have found the height of this broken part, and sorry, the length of this broken part. So this length, that is 13 meter, and this length, that is 5 meter. So if you straighten it up, it means that 5 plus 13. 5 plus 13 means what? 18. 5 plus 13 means what? 18. It means that if this tree is straightened up again, then this will be the height. That is h will be 18 meter.